What if I told you that everything you see, everything you know, the stars, planets, galaxies, and even time itself, had a beginning? Today, we're diving into the greatest story ever told, the birth of the universe. How did everything start from nothing? What happened before time even existed? And how did this explosion of energy eventually lead to galaxies, stars, planets, and life itself? In this video, we'll take a step-by-step journey through the Big Bang and beyond, breaking down complex physics into a story anyone can understand. So, buckle up, because we're traveling 13.8 billion years back in time. Before the Big Bang, there was nothing. No space, no time, no stars. Just an empty void. Or maybe, something even stranger, something we can't yet comprehend. But then, something changed. Boom! The universe was born. In the Planck Era, lasting just 10 cubed seconds, the universe was a tiny, infinitely hot, and dense singularity, smaller than an atom but containing all the energy that would eventually form everything we see today. At this stage, the four fundamental forces, gravity, electromagnetism, and the weak and strong nuclear forces, were combined into one unified force. But we still don't fully understand how this worked because our physics breaks down at this moment. It's like trying to understand what happened before time began. It's a puzzle we haven't solved yet. But the next step? That's where things get truly insane. Imagine a tiny balloon suddenly expanding to the size of a galaxy in a fraction of a second. That's what happened during cosmic inflation. The universe grew exponentially in an instant, expanding trillions of times its original size faster than the speed of light. But don't worry, this doesn't break Einstein's laws, because space itself can stretch faster than light. Why does this matter? Because inflation spread everything out perfectly evenly, giving us the smooth and structured universe we see today. Without this, our universe might have been a chaotic mess. During this period, tiny quantum fluctuations, random energy ripples, were stretched out. These tiny ripples later became galaxies, stars, and planets. Yes! The very structure of our universe was created in this moment. Now that the universe has expanded, it begins to cool down, but not by much. The temperature is still a mind-blowing trillion degrees, hotter than the core of any star. At this point, the universe is filled with a Quark-Gluon Plasma, a hot, chaotic sea of the tiniest building blocks of matter. Quarks, which will later form protons and neutrons, and gluons, which hold particles together, move freely in this superheated soup. But here's the crazy part: matter and antimatter were created in equal amounts. Normally, they should have annihilated each other, leaving behind nothing but energy. So why do we exist? Because of an unexplained tiny imbalance, for every billion antimatter particles, there were 1,000,001,000 matter particles. That tiny leftover bit became everything. Now, 3 minutes have passed. The universe has cooled down to about 1,000,000,000 degrees, still crazy hot, but cool enough for atomic nuclei to form. Protons and neutrons finally combine to form hydrogen and helium nuclei, the first real elements of the universe. But electrons are still moving too fast to attach, so complete atoms can't exist yet. At this stage, the universe is still a dense, hot fog. Light can't escape yet. But don't worry, change is coming. After 380,000 years, something amazing happens. Electrons finally slow down enough to attach to nuclei, forming the first neutral atoms. And as a result, light is free to travel for the first time. This first light is called the cosmic microwave background, CMB, a glow of radiation that still exists today, stretching across the universe. Scientists have actually mapped it, and it shows us what the early universe looked like. If you've ever seen static on an old TV, some of that fuzz is actually leftover radiation from the Big Bang. Pretty mind-blowing, right? After the first light, the universe entered a long dark age. There were no stars, just vast clouds of hydrogen gas. But then, gravity got to work. The first massive stars ignited, creating heavier elements like carbon and oxygen, the ingredients for life. Some of these stars exploded as supernovae, spreading elements across space. Then, about 1 billion years after the Big Bang, the first galaxies formed, including our own Milky Way. And from these galaxies came planets, solar systems, and eventually, us. And here we are, 13.8 billion years later, looking back at our cosmic origins. But the biggest mystery remains: what happens next? Will the universe expand forever, or will it collapse in a big crunch? Only time will tell. If you loved this journey through time, hit like and subscribe for more mind-blowing space content.